Silence. Order. I have returned to the demo scene. To all those people who were so mean, I will destroy everything they got. Make me your leader, vote for evil bot.
Okay, so hello and welcome to my talk. It was intended to be some kind of 8 minutes talks. Now I've got half an hour, so I will extend it a bit just by showing the stuff I only wanted to talk about. What I wanted to talk about is this year, or this year. My friends call it a DemoBlaster because it's for playing demos, and it's a machine with LEDs, 32 by 16 LEDs. So I've got half a kilo of LEDs and try to make something with it. And I want to show you how easy it is really to come up with a platform like this so you can take on a wild comp on your own. So it all started with a failure. I bought some LED stripes, so you know the one you can glue onto something and then take them to get something, to get some images out there. And I bought it, I think it was a safe guess because it also had not only had a connection board for a Raspberry Pi, but also for an Arduino. And it took me about 2 weeks, every spare minute of my free time, and it just wouldn't work. I couldn't get it to work. So I just threw him away and gave him a new retry, or a new try. And the new try is this one. It begins with a translucent briefcase. It was bought on eBay by a manufacturer who's specialized for creating blister wrappings. I was really strange when I saw. It was really strange feeling when I saw the sticker who sent it to me. So, as already told, we've got 32 by 16 LEDs. I bought this one from the States by a company called RGB123.com because they were already pre-soldered on a board. It was already, everything was done. I just had to plug in some connectors. The only thing I had to solder was to solder the power connector. That was the only time I ever had to solder something. And for the grid, I took a CNC milling cutter and just cut out something like 50 boards that I could stack in each other to get this grid form. And there came over some paint, and then the stuff was also finished. The board in itself is we have the ribbon cable connected to a microcontroller that's called Fate Candy. This is an open source and open hardware project. And it comes out with a UGB port so you can connect it to virtually anything. Anything in my case was the Raspberry Pi 2. Gesundheit. I took it because it has just, from what I would assume, the longest maintenance phase of all these little ARM boards out there. And it was the one that was from the Raspberry Pi series, it was the one with the most power. We also have a pair of speakers. These were just some USB-powered 3.5 millimeter jack speakers for the PCs to put them aside, and I just tore off the casing. I also bought some extension cables for HDMI, USB, and the LAN port, so that the machine in itself can also work as a computer. So what you see there is something called a laptop. This is almost a notebook, except that it lacks the main board. It was originally intended that you can put a phone into there and then use the phone like a desktop computer. We also need a power supply because the LEDs are rather power hungry. They take up to the manual something like 120, 150 watts. This is the 120 watts was something that I could really drive them to if I get them all to wide and maximum capacity. And we also need something just for fun, a minion. It's also inside the case. It's also something to get the talk started. Oh, there's a minion. So from the software side, not only, as I said, the Fate Candy is an open hardware and an open software project. So the software is already available, and you get a server that's running a protocol called Open Pixel Control. And there are from the Fate Candy project, there are libraries available for C++, Python, Perl, and other languages. The original Open Pixel Control implementation also has a client written in C, which I took and extended a bit just to fit my needs because I had more fun writing my demo in C than C++. And you can send data from anything that can handle binary data in TCP/IP. Maybe I once want to try it with the Z64, but I'm not sure about this. So how to get, or the whole structure, the whole protocol stuff is you have got the LEDs. They are driven via a bus, a proprietary bus. The bus is run by a Fate Candy microcontroller. Then the Fate Candy microcontroller is connected via USB to the Fate Candy server. The Fate Candy server in itself can be connected by TCP/IP, and the TCP/IP is then connecting from my payload code. I'm using the GD library for generating the graphics. There's the original library and my little helper code that extended this one. And this architecture has a huge advantage because you can just go via TCP/IP from another machine, from a development machine, and do not code your stuff on a Raspberry Pi. You can use your normal PC. So why did I? It was fun. I wanted to show that I suck at creating hardware. I cannot do some FPGA stuff like this. I just took stuff off the shelf and put them together. And it worked in the second run. And also I had a really fun part about it when I showed it around, especially to guys that are not into the demo scene. They were also already wondering, oh man, I could use it for this, I could use it for that. Oh, maybe that would look good on stage or something like this. It's already triggering imagination just showing one demo. And everyone wants to do something with it. So, to my conclusion. Building with almost no soldering is possible. The complete software stack is available. Since Fate Candy is a USB device, you can almost anything use to drive it. I chose the Raspberry Pi because it was easy to implement. You can also use something like an x86, a really fat PC. You can use a really small microcontroller, everything in between. Clients from OS X and Windows are also available. So maybe if you want to do a PC demo, you can use a panel as a side for side-to-side enjoyment or something like this. And I've paid, on my experimenting with stuff, I paid on one point a steep price of several pizzas because as I can solder, I'm really not good at this. Some LEDs broke when I drove them really with maximum capacity. Because in this casing, they are getting a bit too hot and it wears them down. I will run a demo on this one, and this is already only 50% of the maximum, and it's still way bright enough. So my tip for that, so that you don't break anything, half of the output capacity is enough. And on the software side, if you can see, or as we see it at the demo, if you're going to do something on this, to get an impression that you've got more space to put your stuff on than you really have, you've got to use movement And also to get the stuff a bit more fluent running, you should use oversampling. So I'm almost at no time calculating something like 20 by 13 LEDs up. I'm doing something like not 320 by 160, but something in between in there. And then I'm scaling it down. It looks way better than calculating just for the few LEDs. So this was the part of my talk. Before we can get to the demonstration, are there any questions? Mike, please. Can we get a mic for the questions? There was someone with a microphone coming my way. Then he went back. Here, to the front.
Yeah. I'm just was wondering the time to update the complete LED regarding the time of making a buffer in memory of your PC.
Yeah.
Just to understand if your PC is far more faster than the time to update the complete panel. Is that something we should buffer or something?
You don't have to think on the LEDs in something like frames per second. If you put an image on, it stays there on as long as you put the next image in there. To be more specific, the Fate Candy software itself, if you have a picture going on for 2 seconds, then move the next one in, it takes itself 2 seconds just to transfer the image by dimming to the other image. So you already got some nice effects just by doing a delay. So I'm usually running by calculating 25 frames per second, and then just doing a wait until these 40 milliseconds have passed, and then putting out the next image.
Yeah, but then should you send some kind of command to the Raspberry Pi to update just not the whole screen, but just
no? The Open Control Protocol only allows to put on a whole screen.
Okay.
But it's something 512 LEDs. You've got RGB, so I've got the triple of them plus a little header. So you've got slightly under 1600 bytes sent over USB. So what? Yes.
So how many?
Even if you do it, even if you do it 1,000 times per second, you've got something like 1.6 megabytes. Even the slowest USB is capable of this. So there's no need to put them down.
Yeah. Okay. So you try it, and then you can flood you can actually switch image as much as you want.
Yeah. Okay. I can at some point just there are some points that gets something like frame drops or something like this, because you're putting the images in way too fast. But I tried it with some specific settings, and I noticed that with the LEDs, because they also transfer a bit from image to image, 25 frames per second is really enough. You will see it.
Yeah, thanks.
Hi, I would like to know if you need to dissipate the heat inside the case.
I didn't, and when I reduced the maximum light output of the LEDs, since then I've had no problems. So the thing gets, you can touch it, it gets about slightly above room temperature.
Okay, thanks.
Any more questions? There are two.
I was wondering, like, on 120 watts seems really high for LEDs. Is there any way? Because maybe if I was trying to do something with LEDs, is there any way not to use a PSU? And
you can go it down just by the dimming stuff. The demo in itself, when you see it running, it takes about 20 watts in total at the peak, maybe 25, but that's really the max. So the 120 watts is really, each of these LEDs are 3 tiny LEDs, red, green, and blue. And if I put all these 1,500 LEDs on all at the same time, then they are using the 120 watts.
Okay, thanks.
There were also 2 back there.
Hi, is the number of LEDs limited?
The Fate Candy controller can, with a nice incidence, drive exactly 512 LEDs. But what you can do is you can use more than one Fate Candy controller. There's also available for the microcontroller something with black. Help me there. No, not the black fin. BeagleBone Black, thanks. There is also a cape, it's called there, the additional board, which can drive already, I think, 6 times the 512 LEDs of a Fate Candy controller. And what you can also do is just add more USB controllers, and you can then cascade them using a configuration file.
Okay, thanks. So what is the total cost of the project, of this case and all the stuff inside?
This is really a unique thing. I was already asked if I could build another one, but as I noticed back then, just to ensure that it's not possible, that the case was not on eBay at this time. And another problem that you've got right now is that the manufacturer of the LED board in its store, in its online store, does not have at that moment the 32 by 16, but only 16 by 16 boards. You can still use 2 of the 16 by 16 boards, but it's not really so easy reproducible as it is right now, and it has cost something. The board has cost, I can break it down for you so I don't get the total number. The board had cost $160 plus shipping. The microcontroller was in the same shipment, so it was something like $20, $25. Raspberry Pi is something like $35, 35 euros. And the rest of the stuff are something like you can buy for 20 euros at most. So if I put it all together, I come to something like 250 up to, the case also costed something like 20 euros. So if I come up to something like 250 to 300. And it took me something like 9 months to a year to build, but it was really a side project. So I really did something, when I had an idea, something like, at first there only was the LED board. I came up with the idea for the case much later. So I bought the case and then was how to fit it in there. Then came, okay, I need the power supply put in there as well. Then, okay, no, I've got this. Maybe I should put in something intelligent in there so I can drive it from the inside. And so it all built up. And I'm not sure if I'm really finished yet, because this has no battery right now, and I'm thinking about maybe using something like notebook batteries to get this also portable, to be a real DemoBlaster. So, any more questions? In the back, there's one.
How can you make sure the timing is consistent? Consider this. The whole system is controlled basically by a Raspberry Pi, which in itself isn't so fast. But perhaps the Raspberry Pi is locked up in some process, then your frame rate, as I can put it this way, may drop. Fades may not be consistent, timings may not be always the same. How can you make that consistent?
I made it consistent by adding enough horsepower. This is Raspberry Pi 2, this is a quad-core machine. And even if some process runs up renegading, it's one CPU. If I do a normal plasma, it does compute something like 10% of one core. So if you go for the C++, engine I mentioned earlier, with this one I can drive up all 4 cores to something like 50%, and I can even go for more if I add more effects. Because the C++ framework acts something like a shader. So it asks for each LED which should be the color, and so you've got a lot of transitions, and you've got, it's also using float for addressing, so this is also getting slower, and this adds up. But this was also one of the courses I switched to C for coding, and in using C, the demo would run fine using the Raspberry Pi 1. So really the slow one with the 700 megahertz and just one core. Assuming non-process would renegade, and the key to this one was just testing. Running the demo over and over again during development, and it turned up somewhat stable, so I didn't need to look into this one. And also for getting a really consistent frame rate, I've been using timers so that I'm just waiting or just triggering a delay before I start calculating my frame and waiting the amount of time that I need to get up to these 25 milliseconds. And there was also one question up in the back I saw, or was this you? So any more questions? I see some movement, but no question. Okay. The machine takes something like 30 seconds to boot up.
I don't understand. There is no intelligence inside.
The Raspberry Pi 2.
Ah, sorry.
This one is a Linux machine and it
I
needs...
thought it was in the middle.
It's Linux-based. It's the original Raspbian. What's running in there? This is the boot logo of the machine. So, let me also make this stuff a bit louder. I didn't want to wake up the hotel. It's at the max. You don't need to film it, it's already on YouTube.
I guess there is no VBS situation, no sync.
No, the sync I had to code myself again, as on the Atari VCS. So I just wait 25 milliseconds before putting on the next image. Thanks. And one more thing for the last. Since when you run it without the console, just via network, you need to know to which is the IP to connect to. For this one, it's the little back display. So, any questions left, or can we now all go drinking?
Sorry. we'll drink later. You just mentioned that actually it could run on a Raspberry Pi 1.
Yes. The question was that I mentioned that it's good to run on a Raspberry Pi 1. So, what's the question?
The question was, just I'm curious, how do you manage to pilot the Raspberry Pi 1 to do the screen animation, do the LED lighting, and the music at the same time?
I just simply coded a lightweight OGG-Forbes decoder using the standard libraries. And for OGG-Forbes decoding, it needs something like 5 to 10%. That is the old Raspberry Pi 1.
So you use a native thread of the
Yeah.
Unix. Okay, it's enough.
Yeah, native thread is enough. And I'm also using...
Don't need an Arduino to be more precise.
what I did was that my little player also can request the actual time slot the OGG-Forbes is on. So I can wait until a special part of a music, which happens for something like a tenth of a second or something like this, when the screen went black from effect to effect.
Okay, but the LED doesn't need more precise timing.
No. The question was that the LED need more precise timing. No, they don't. And of course, I stuck with the Raspberry Pi 2 instead of the Raspberry Pi 1, just to have more buffer and not to be forced to code so much on the edge. Or solve a problem in software when you can solve it in hardware. There also is another question?
Yeah, I can just ask, have you thought about using like a microcontroller to drive it, something like an 8-bit or not very powerful?
The question was if I was thinking about running the LEDs with just a microcontroller, something very low power. No, I didn't, because I just wanted to put it together by standard components, and a Raspberry Pi is so cheap, there was no point in it. And since there also was some kind of time frame, stuff like this, and I wanted to use it as much as possible in as much as possible ways, the next thing I want to do is to write some kind of snake on it. I already started with this one. And sorry, a microcontroller is there a bit of a pain in the ass without the need for. Anything else? Hey, drinking.